Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing inequalities. This is standard A.3D in the great state of Texas, and we are using item number 45 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we actually have the graph of a linear equation already plotted out for us here. 2x minus 5y equals 10. And we need to find which ordered pair is in the solution set of everything's the same except that equals has now turned into an inequality, greater than or equal to. So the difference is when you have an inequality like that, you need to decide two things. First, is it going to be a dotted line or a dashed line? And here's the difference. When you have a greater than or equal to, or when you have a less than or equal to, it means you're going to have a solid line because you're going to include the numbers that are on that line in the solution set. So it is a greater than or equal to, so we can keep that solid line. If it was greater than or less than, no equal to, then it would be a dashed or a dotted line, just because you couldn't include any numbers on that line in the solution set. It would get up to that point but not above. Then that's just what type of line it is. Now we need to decide how we're shading it, because it's a solution set, so it's any numbers that fall on either side of that line. So when we're dealing with greater than or equal to, greater means above, so we're going to shade actually above the line. That means any number falling above the line would work. Less than or equal to, or less than, less means below. We're actually going to shade below the line. And you know what? Just because we have a greater than doesn't mean that's exactly what we need, because it needs to be in slope-intercept form. And right now it is not. It's actually in standard form. Right? So what we need to do is we need to translate this into our slope-intercept form. That means we just simply need to solve for y. So let's look at it like this. 2x minus 5y greater than or equal to 10. So we're going to subtract 2x from both sides. Negative 5y greater than or equal to negative 2x plus 10. Here's the problem. We need to get rid of that negative 5 by dividing both sides by negative 5. When you divide or multiply by negative, you actually flip the inequality. So now it's going to be y is less than or equal to, because I divided by a negative. Now it's going to be negative 2x over 5. You can distribute this out, so that's going to be just 2/5 x. And then that's 10 over negative 5. That's going to be minus 2. So now, here's my actual inequality in slope-intercept form. Same thing. You notice I've got a 2/5, so that means the slope is going up 2 over 5, the rise over run. Right, I've got my y-intercept of negative 2, and it's a less than or equal to, which means I need to shade below. All right, so now that I know which way to shade, let's plot these points. Okay, so 0, 5. This is A. Does not fall in the solution set. 5, 0. Looks like it's right there on the line. C is going to be negative 2, 5. Still not in the solution set. And then negative 5, 2. Not in the solution set. So even if we didn't know all those things, if we plotted all four, we'd see only one of them is actually on the line. So plugging in what we think our solution is here, our y is 0, less than or equal to 2/5, and then my x is 5, and then minus 2, so that's just going to be 0 is less than or equal to, that just becomes 2 minus 2. 0 is less than or equal to 0, which is actually true here. So our answer is B.